All right, coming back, doing more problems. All right, let me get my range here. Let's see here. So, all right, well, I'm going to pick up in 6.2. I've kind of skipped around a little bit now, so let me try and go back and knock out. I'm going to do 23, 25, 27. So 23 is tangent to the fifth, secant to the fourth. Tangent to the fifth, secant to the fourth. So I've got integral tangent to the fifth x, secant to the fourth x dx. Now, if we go and we look at our techniques here, we have secant and tangent together, and I'm going to be able to peel off here one factor of tangent, so that's going to be tangent to the fourth instead of tangent to the fifth, one factor of secant, so that's secant cubed instead of secant to the fourth, and then here's that factor of secant that I pulled off, here's the factor of tangent that I pulled off. And in doing this, what we realize is that this right here is the derivative of secant. So u, for me in this problem, will be secant x, and the derivative of that is exactly what we have there, secant x tangent x dx. And so when I go to rewrite the problem, I'll be able to write this as u cubed, and that'll be du, but I need to figure out what tangent to the fourth is, and I need to get it in terms of u. So what I'm going to do is I'm going to rewrite tangent using the Pythagorean identity. So remember, 1 plus tangent squared x is secant squared x. So if I subtract 1 from both sides of this equation, you get that tangent squared x is secant squared x minus 1. So this piece right here becomes secant squared x minus 1 quantity squared. So be careful because it's tangent to the fourth. That's actually tangent squared, and then the tangent squared is this, and then you have to square it. So then we've got secant cubed x, and then secant x tangent x dx. And now we'll be able to do our substitution because everything is in terms of u or du. So we've got integral, and then we have in parentheses u squared minus 1, that quantity squared, then times u cubed, and then all of this is du. And then I'll expand out this binomial, so it becomes u to the fourth minus 2u squared plus 1. Then I still have u cubed du. And at this point, I can distribute the u cubed through the parentheses. So here, here, and here. So I've got u to the 7th minus 2u to the 5th, and then plus u cubed, and then du. And now I'll just integrate each of these using the power rule. So we have 1/8 u to the 8th minus, let's see, this is going to be 1/6 u to the 6th. That 1/6 hits the 2 there with the multiplication, becomes a 1/3 u to the 6th, and then plus 1/4 u to the 4th plus a constant. And now replace all our u's with secants. So we had 1/8 secant to the 8th x minus 1/3 secant to the 6th x, and then plus 1/4 secant to the 4th x plus c. And that should be our result. Over here. Okay, now we're going to move on to number 25, which is tangent cubed times secant. So I'm not going to do the evens anymore because I assigned those for homework. I mean, I didn't assign those for homework, and this is taking me too long. Tangent cubed secant. Yes. Tangent cubed x secant x dx. So I think I'm going to play the same game here. I'm going to try peeling off one factor of tangent, which makes that tangent squared x, and one factor of secant. But secant, just going to use that one. Secant x. There's the tangent I peeled off. So this right here, that's the derivative of secant. So u will be secant x, du, secant x, tangent x, dx. So I know that this is du, but I need u, I need secant, and tangent is not secant. So I just use the Pythagorean identity. Again, tangent squared x is secant squared x minus 1. We just used that in the previous problem. And then at this point, we can go straight to the substitution. This is u squared minus 1 times du. And that's a pretty straightforward power rule here. 1/3 u cubed minus u plus a constant. And then this is 1/3 secant was u, so secant cubed x minus u, which is just secant x plus a constant. And that's it for 25. And then 27 is tangent to the fifth. Just tangent to the fifth. Or I should say number 27? 27. Number 27 is just tangent to the fifth. All right, so we don't have any secants here at all. So because we don't have any secants, let's see what the rule says that if we were to have tangent, if tangent is odd, it says save a factor of secant tangent. Well, I don't see a factor of secant, so how am I supposed to do that? Well, there's a couple of ways you can do this problem, but let's try this for a second. Let's go with this. Let's first convert this into what tangent to the fifth means, which is this. So I'm kind of stuck because I don't see any secant, so I just put everything in terms of sine and cosine. That's kind of a rule of thumb if you ever get stuck on something with trig functions. Just try and get it in terms of sine and cosine. So here I know that if I let u be sine, the derivative is in the bottom. I don't like that. If I let u be cosine, the derivative of it is up on top, which is better, but it's to the fifth power. We've kind of seen this before. I'm going to try this. Derivative of cosine x is negative sine x. So negative du will be sine x dx. So if I let u be cosine, the bottom, then the derivative I have up top, but I actually have 5 factors of it. So I'll just peel one of the factors off. So that'll leave me sine to the 4th x on top, cosine to the 5th still, and then here's that one factor of sine that I peeled off. And so you notice that that factor I peeled off right here, that can be replaced with du. So now what I'll do is I'll rewrite this integral. I've got to figure out what to do with the sine up on top. So how about we rewrite that as sine squared over cosine to the 5th x. Then here's my sine x dx. So just rewriting this. And then remembering by the Pythagorean identity that sine squared x is 1 minus cosine squared x, but then that quantity is squared, and then over cosine to the 5th x, and then we have sine x dx. And so you can see now we've got everything rewritten. So we've got u's, right, u is cosine. U's are in here, and then there's negative du right there. So I'll rewrite the integral now in terms of u. All right, we have in parentheses 1 minus u squared, that quantity squared, over u to the 5th power. Then sine x dx is negative du, so here's du, here's negative. And now I'm ready to try and complete this integral. Got to get all these things so I can use power rule. So here's negative integral. Expand that out. 1 minus 2u squared plus u to the fourth over u to the fifth du. And then I can split this up into three separate terms because I have one term on the bottom, or three separate fractions if you like. Let me do that now. It'll be equal to negative integral, let's see, 1 over u to the fifth is u to the negative 5, minus 2, and then u squared over u to the fifth is u to the negative 3, and then plus u to the fourth over u to the fifth is 1 over u. I'm writing it as 1 over u instead of u to the negative 1 because it's easier for me to recognize that the antiderivative of that's natural log. So I don't like the negative up out front. That's just my preference. So I'm going to make this negative u to the negative 5 plus 2u to the negative 3 minus 1 over u du. So just distributing the negative through. And then now we'll just use power rule. So this is equal to, all right, I have a negative. I'll put negative 1 times antiderivative of this. I add 1 to that, get negative 4. So I got 1 over negative 4 u to the negative 4 plus 2 times, now here same thing, add 1 to negative 3, I get negative 2, so 1 over negative 2 u to the negative 2, and then we said just a second ago the antiderivative 1 over u is natural log of u, and then plus c. And then let me try and just get a final answer here. Negative and negative is positive, that's just 1/4, and then u to the negative 4 means u to the fourth on the bottom, and then plus, let's see, oh, actually it's going to be minus 2 and negative 1/2, that gives me a negative 1. U to the negative 2 is 1 over u squared. And then over here we have minus natural log of u plus c. And u was cosine x. So let me rewrite this. So here we get 1 over 4 cosine to the fourth x, and then minus 1 over cosine squared x, that's this, and then minus natural log of the absolute value of cosine x plus c. And we could go one more step because 1 over cosine is secant. So I could rewrite these if I wanted to, as I still have a 1/4, but this 1 over cosine of the fourth is secant to the fourth x. This one right here would be secant squared x, and then minus natural log cosine of x and plus c. And the book might even take that negative and put it up here and make that 1 over cosine and make that a secant. Let me see if this one has an answer real quick, what they do with that. Yeah, they do that at the end. Where is it? Secant to the 1. Oh, 1 over 2. Yeah, I think I got this. Yeah, check. That doesn't. That looks like there might be a little mistake in the solutions. I'll double check it and come back and correct the video if there appears to be a problem in the solution, but I may have made a mistake. I don't see anything. So again, this right here, they put the negative up here and make this like cosine to the negative 1, which is 1 over cosine, which is secant. So it changes this to plus natural log secant x. The book is saying that this should be tangent squared. I'll go back. I'll check it later. I need to move on. I think you got the gist of the problem. That's the most important thing. Okay, so that's it for the trig integrals. Now I'm going to do the trig substitution, which I believe I've done most of the problems. I need to do number 49 and number 51. So number 49. It's integral square root 1 minus 4x squared dx. So this is a problem where we see we almost have the format that we want. We almost have this, except that we don't have a 1 in front of x squared. So What I showed you in class is that we can make that a 1 by factoring a 4 out. So I need to pull a 4 out and then rewrite these two terms. So that means this first term has to be 1/4. So that when I distribute through, I get a 1, and then I get minus x squared, and then dx. So that takes care of trying to get it to look like this. Now, the square root of 4 can come out because square root of 4 is 2. So 2 comes out and then goes outside the integral. So we get 2 integral square root 1/4 minus x squared dx. And now, at this point, we can go to our substitution. And the substitution we make when we see that is x is equal to a sine theta. So recall that this right here is a squared. So if you take the square root, you get 1/2. So the substitution I'm supposed to use is this one. So what I'll actually be working with is 1/2 sine theta. That's what I'm going to use. So from this, I get my pieces of information. I take the derivative here. dx is 1/2 cosine theta d theta. And then the square root of 1/4 minus x squared, which is the square root part, is the square root of 1/4 minus, now I'm squaring x, so here's x right here. Square it, you get 1/4 sine squared theta. Factor out a 1/4. I'm going off the video here. Come back up here with it. Factor out the 1/4. And then you're left here with 1 minus sine squared theta. And then that's square root of 1/4. And this is cosine squared theta. And now take the square root, you get 1/2 cosine theta. So I will replace this square root with 1/2 cosine theta. I'll replace all my x's with 1/2 sine theta. I'll replace dx with 1/2 cosine theta d theta. And I'm doing that in this problem right here. So I have my 2 outside integral. The square root part is this, 1/2 cosine theta times just dx, which is this, so 1/2 cosine theta d theta. And now what I can do, I can take my constants out. 1/2 times 1/2 is 1/4, times 2 is 1/2. Integral, cosine times cosine is cosine squared, theta d theta. And now this one is cosine to an even power. So I use the power reducing formula. Huh, what do you think about that? Cosine to theta. You know who I'm talking to. All right, so use that, and then take the 1/2 out again. So 1/4 integral 1 plus cosine to theta d theta. And now I can integrate each of these term by term. So the antiderivative, see 1/4, antiderivative of 1 with respect to theta is theta. Antiderivative cosine 2 theta is 1/2 sine 2 theta. We've had this happen several times now. And now I need to recover what theta is in sine of 2 theta. Now, because I've done this a couple of times, we know that this becomes 2 sine theta cosine theta. The 2 hits the 1/2 and goes away. So we should just have sine theta cosine theta plus a c. So I'm going to need a reference triangle. Remembering that I had made the substitution, x is 1/2 sine theta. I can multiply both sides by 2 and get 2x equals sine theta, which I'll look as a fraction. 2x over 1 is sine theta. And then I draw a right triangle off that. Here's theta. Sine is the opposite over hypotenuse, and that forces this side to be 1 squared minus 2x squared, which is, or 2x, that quantity squared, which is 4x squared. And that should look familiar. All right, so now our answer, 1/2, oh, I forgot to get what theta is. Right here, just take arc sine on both sides. So arc sine 2x equals arc sine of theta, which is theta. So I have 1/4, and then theta, which is arc sine 2x, and then plus sine theta, which is just 2x, times cosine theta, which is this over 1, which is just this, plus c. And I hope that's all coming out. It's close, but it's working. All right, that's number, forgot which one that was. That was 49, so let me do 51. Integral square root x squared minus 9 over x cubed dx. Well, the good news is that what's in the square root is exactly the form that we like. It looks like the square root of x squared minus a squared. And the number in front of x is 1, so we are just going to use the substitution x is a secant theta. So I'm using the substitution x is equal to a secant theta. And in this problem, a is 3 because the square root of 9 is 3. So x is equal to 3 secant theta. And now I take the derivative. Dx is 3 secant theta tangent theta d theta. And the square root part of, what is it, x squared minus 9 becomes square root of my x right here, squared, 9 secant squared theta, minus 9. And then you factor out a 9. You're left with secant squared theta minus 1. But that's 9 tangent squared theta using the Pythagorean identity, which is 3 tangent theta. I hope this isn't going too fast. I feel like I've done enough of these, hopefully, that you're following, and that marker was terrible, that you're following, all these identities and stuff. All right, so I'm ready to rewrite the integral. So I have this equals, oh, that's much better. The square root part turns out to be 3 tangent theta over x cubed. Interesting. So I'm going to take this and cube it. So that means 3 times 3 times 3, that's 27. And secant times secant times secant, which is secant cubed, theta, times, now dx, which is 3 secant theta, tangent theta, d theta. And we get some canceling here, right? The top multiplies to be 9, right? 9 over 27 is a 1/3, so I can take a 1/3 out. That. And then, so I've taken care of this. Oh, sorry, that. I get a tangent squared on top. And then one of my secants cancels with one of these factors, creates a secant squared on the bottom. So I've got tangent squared theta over secant squared theta. I do have tangents and secants mixed up, but one's in the numerator, one's in the denominator. So I think it'd be a little bit better for us if we rewrite everything in terms of sine and cosine. So the top is sine squared theta over cosine squared theta, that's tangent squared theta, over secant squared theta, which is 1 over cosine squared theta, and then d theta. And then when you flip this fraction up, the cosines cancel. So all you're left with is 1/3 sine squared theta d theta. And on this, we've got an even power of sine, so what do we use? What do we use? What's it called? Oh, the power reducing formula. All right. All right, I can't continue to be an asshole here, I'm sorry. I will just say it's the half angle identity, but I like to call it the power reducing formula. So for those of you who are trying to find the power reducing formula on your formula sheet, it's actually called the half angle identity. So this right here becomes 1/2 1 minus cosine 2 theta d theta. All right, I continue. All right, 1/6, 1/2 came out. 1 minus cosine 2 theta d theta. And now I'm going to integrate each one of these term by term. 1/6 antiderivative of 1 is theta, minus 1/2 sine 2 theta, and then plus c. And I already know what's going to happen here because I've done this 1,000 times. This is going to be minus sine theta cosine theta plus c, right? And now I just need to figure out what that information is. So I go back to my substitution, which, geez, I don't even remember what it was. I don't remember what it was. The number was 53. 53, so we had used the substitution x equals 3 secant theta. Yes, I think that's what it was. X was 3 secant theta. And so x over 3 is secant theta. Reference triangle off of that theta. So secant's the reciprocal of cosine, so this should be x over 3. And then that's square root of x squared minus 9. Good, that matches what I started with. And I also need theta. I can get that from here. Theta equals the arcsecant of x over 3. That's really close to being off the edge of the video, in fact. Oh no, it's there. Okay. And so now, where the heck am I? Right here. So this is equal to 1/6 theta, which is secant inverse of x over 3. And then minus sine theta. Sine is opposite over hypotenuse, so this over this. Root x squared minus 9 over x times cosine theta, which is 3 over x. 3 over x plus a constant. And I can slap the 3 out in front of the root, and I can put the x's together in the bottom as x squared. And that should be 53, or 51. See, 1, 6, yeah, they distributed through, so. All right, I think I've got that. All right, I need to go check the homework assignment rule because I don't have it with me to make sure I'm getting the right problems done here. Just give me a second. So sorry about that delay. So what was that problem that I had done? 49. Yeah, I don't know. I'd have to go back and look at the video. Oh wait, it was 27. Let me just look at something real quick. I'm going to have to look at 27 again. They did it a completely different way. So I'll have to look at it and make sure that what I did was correct. But for now, let's continue. This was correct. I noticed in the back of the book it looked like there was a typo on the solutions on the one I just did. Just a little, there's a 2x on the bottom that's supposed to, the 2 is not supposed to be squared. But don't worry about that. Okay, so according to what I've said, I'm supposed to continue working through these 53, 57, 53, 55, 57, 59, and 61. So let me look at 53. Integral x squared over 9 minus 25x squared. X squared over square root of 9 minus 25x squared. Gosh, I feel like I've done this problem. Okay, so I'm going to move fast through this. I know I've been moving quick already. But this looks like a squared minus x squared, except I don't have a 1. So I factor out the 25 first. So when I do that, I have 25 here. This becomes 9 over 25. That's what I need to get that 9 back, minus x squared dx. And then the square root of 25 is 5, so I can take it out, and then it comes out as a 1/5 integral x squared over square root of everything that's left here, which is 9 over 25 minus x squared dx. All right, so I'm going to make the substitution. X is equal to a sine theta. So x is equal, in our case, a is the square root of this. The square root of that is 3/5 sine theta. Hey, what's up? Come on in. Oh, you have something at 10? Okay.
Go ahead, because I don't know if you show.
Okay. Yeah, if they don't show up, that's fine.
Yeah.
Okay. I'll at least finish this one problem.
No worries.
So we take the derivative, and then we determine what the square root part of this is, which is this. Now we have to square our x. So when we square our x, we get 9/25 sine squared theta. We factor out our 9/25. We get 1 minus sine squared theta. And then convert that over to cosine squared theta. And at that point, we can say it's 3/5 cosine theta. All right, so we've got our 3 parts here. And now we're just going to go and rewrite the integral. So we're going to rewrite this one right here with all that information. Let's see what this text was. Blah, blah, blah. All right, so I have 1/5 integral. Now x squared on top, which is going to mean we square this, which will be 9/25, and then sine squared theta over the root thing, which is the 3/5 cosine theta, and then dx, which is replaced with 3/5 cosine theta d theta. We get some nice cancellation here. So we get our 3/5 cosine theta is completely canceled, which leaves us with a 9/25 sine squared theta d theta. I can factor out, I know we did this problem. Let's see, 9 over 125, that's when I pull that out. Got integral sine squared theta d theta. And I get to use that half angle identity. at this point to rewrite the sine squared theta. It's called the half angle identity. Don't let anyone tell you anything else. 1/2, 1 minus cosine 2 theta, d theta. And then pull the 1/2 out, so 9 over 250 integral, see 1 minus cosine 2 theta, d theta. And then let's integrate term by term. So we'll get 9 over 250, and then antiderivative of 1 with respect to theta is theta, and then minus 1/2 sine 2 theta, and then plus our constant of integration. And then we've done that a couple of times now. Let's see here. We have 9 over 250 theta minus sine theta cosine theta. That's using the double angle identity. And now I'm going to create my reference triangle based off of my initial substitution, which was x is equal to 3/5 sine theta. So here's my reference triangle. I'm going to just multiply by the reciprocal. So I'm going to get 5x over 3 is sine theta. While I'm here, may as well get theta. So arc sine of 5x over 3 equals theta. And then from here, let's draw the triangle. So 5x is the opposite side, and the hypotenuse is going to be 3. And now we set up our adjacent side. It's going to be 9 minus 25x squared. And that should look familiar. That was in the original problem. And now I'm ready to write this down, get my final answer. All right, theta is arc sine of 5x over 3 minus sine theta, which is 5x over 3, times cosine theta, which is the square root 9 minus 25x squared over 3 again, plus our constant of integration. I don't feel like cleaning this up anymore, but you put these together and get your 9. Oh, they would cancel, and then you, well, it's not too bad. I'll do it. Okay, so we have 9 over 250 arc sine 5x over 3. And then these two become a 9. That 9 cancels with that 9. And then this 5 reduces this to be 50. So minus 1/50th. And then I have an x. Then I have the root. And plus my constant. There we go. Okay, that was number 53. Okay. So it's all right, I just keep going? Yeah, okay. All right. Oh, 55. 55. Okay. All right. We'll give them some time. If they show up, I'll leave. 55. I was coming in here, I was thinking to myself, I wonder if Amy's doing her thing. It must be like at noon or something. That's what I was thinking.
Usually 10 to noon.
10 to noon? Oh, this one's going to mess you up. Look at. All right. So remember that the issue here is that you get so fixated on doing one method, you forget about all your other methods. Someone's here?
I never got her, she's in math class.
Okay. Tell her to come on in. This one's going to take me like 2 minutes. Okay. All right. So you're thinking trig substitution here, but it's actually just a basic substitution because the derivative of this is up here. We're off by a constant. So this is tricky. You could probably turn this into a disaster if you go ahead and try and work it out with trig substitution, but just a basic substitution here and scaling out so we can get our x dx to match, and then we just rewrite this integral. So this x is going to come out here. We got 1 over root the x squared minus 7 is u, and then x dx is 1/2 du. Here's 1/2, here's du, and then that's just 1/2 integral. This is u to the negative 1/2 du, and Okay, so add 1 to that, you get 1/2. 1 over a half is 2. So we got the 1/2 out here, we got the 2, we've got the u to the 1/2, and then plus our c. And the 2's go away, and that's just square root of u. But u is x squared minus 7 plus c. Oh, that's tricky. 50, that was 55. Why would they have made that a special problem? Okay, I'm going to relocate. How much video? I have 40 minutes. Ah, that's good. Stop the video. Okay, I'm going to pick up on number 57, but I wanted to just make a comment that back on number 27, I did go back through my work, and the work I did was correct. The answer is not going to match the back of the book because they have something like tangent squared, and in our answer, in one of the terms, we have secant squared, but tangent squared of x is the same as secant squared x minus 1. And so the minus 1 is a constant, and so it does not matter. It goes with the plus c, so you can write tangent squared x or secant squared x. And in this case, because it's an antiderivative and we have the c at the end, it's the same answer. So, okay. Number 57. So I already started this one. Here's the integral. We've got a squared plus x squared. That means I'm going to use x equals a, which is 1 tan theta. Here's the derivative, secant squared theta d theta. And then the root turns out to be this. So I'm not showing that work. I'm just going to rewrite the integral now. The top is secant theta. The bottom is tangent theta. And then dx is secant squared theta d theta. Now this is a very tricky problem. All right, I tried working it out once, and it did not work out. Well, it worked out, but then it required that I use a technique from the next section. So I went back and I looked at how they expected you to do it. And this step right here that I'm about to do is really unnatural. So right here, if you try and let u be equal to secant theta, the derivative of that is secant theta tangent theta. You don't have a secant theta tangent theta. So it seems like you couldn't get it that way. If you try and let u be tangent theta, then it seems like the derivative of it is here, secant squared theta d theta. However, you have this secant theta. It's not squared, so you can't get rid of that. You can't write it in terms of u or in terms of tangent. So the way that they do it is they rewrite this as secant theta over tangent theta, and then they rewrite secant squared theta using the Pythagorean identity, like this, which is a totally legal move. And then at this point, they just distribute this through. So let's see what happens. Well, secant theta over tangent theta times 1 is secant theta over tangent theta. And then plus, now secant theta tangent theta times tangent squared theta, one of the tangents cancels. You have 1 on top still, so you have secant theta tangent theta d theta. And the nice thing about this is I know the antiderivative of secant theta tangent theta. It's just secant theta. So I can handle that. I just need to be able to handle this. And this right here, let's just rewrite it in terms of sine and cosine. The top is 1 over cosine. The bottom is sine over cosine. So I already know the answer to this, so I'm not worried about this right now. I'm just looking at this. And then when you flip like this, right, when you flip this, all you get is the cosines will cancel. You get 1 over sine theta, which is integral cosecant theta d theta. And we have a formula for that. So the answer, right, in terms of theta is the antiderivative of cosecant theta, which we go grab out of formula number 15. Right, formula number 15. So it's natural log of cosecant theta minus cotangent theta. That's the antiderivative of cosecant theta. And then we have minus, or no, plus, sorry. That was the antiderivative of this. Then plus the antiderivative of this, which we said was just secant theta. So plus secant theta plus c. That's kind of tricky. And now we go back and we figure out what all those are. So we get a reference triangle. And that's built off of this. X was tan theta. So that's x, that's 1. That's square root of x squared plus 1. And so I fill all this in. Natural log, okay, cosecant theta is the reciprocal of sine. So it's this over this, root x squared plus 1 over x, minus cotangent theta, which is the reciprocal of tangent, so it's 1 over x, plus secant theta, which is the reciprocal of cosine, so it's this over this, and plus c. You could put these together with a common denominator. Since they have a common denominator, you can put them together, and that should be it. Yes. All right, 59. I'm almost done with this section. I'm pretty excited. I'm 2 problems away. Number 59. Integral x root 1 minus x to the 4th dx. Now hold on a second. We have x to the 4th there. We've never seen that before. Never seen that before. It's always been x squared. So I noticed something right away. That if we rewrite this as 1 minus x squared squared, then look, if we let u be x squared, the derivative is 2x, which we have, almost. So I'm going to make a quick substitution. U is x squared in the problem. The derivative is 2x dx. So I'm just using basic substitution right now. Half of du is x dx. So I'll be able to replace the x dx with 1/2 du, and I'll be able to replace this with u squared. So let's with u. So this will become integral. The x dx is going to come in later. Square root of 1 minus, and that right there is u squared. And then the x dx is 1/2 du, so there's 1/2 du. There you go. Now this looks like the format that we have been using the trig sub on. But we had to do a substitution first, so that's kind of tricky. So whenever we see this form, now we need to make a substitution. Now we've been saying if we have a squared minus x squared, we use x equals a sine theta. That's what we've been using. X is a sine theta. But that was assuming that our expression had the variable x in it. Here it's not x, it's u. So we need to use this. U is a sine theta. And I'm getting a phone call. I'll take this real quick. Hello? Okay, there we go. All right, so we're going to be using u instead of x. A is 1 in the problem. So u is going to be 1 sine theta, or just sine theta. Now I do the derivative, cosine theta d theta. And then the square root of 1 minus u squared this time is the square root of 1 minus u is sine squared theta, which is just cosine theta after you clean that up. All right, so now we're going to rewrite this integral. This is 1/2 integral. The square root thing is just cosine theta. And du is du is cosine theta again, d theta. And then that's just 1/2 cosine squared theta d theta. Using the half angle identity is what? 1/2 1 plus cosine 2 theta d theta. And then we integrate each of those. So this is 1/4 integral. We get theta, and then plus 1/2 sine 2 theta plus c. And we know that that's going to turn into 1/4 times theta plus sine theta cosine theta. Right, this thing, we know what that does already. And now I'm going to get my reference triangle. Now be careful here, because the information I'm using is u is sine theta. So u over 1. So u1 square root 1 minus u squared, here's theta. So using this information right here, I can figure out what theta is. It's arc sine of u, and then sine theta is u, and cosine theta is this over this, so square root 1 minus u squared plus c. And then the last step is to replace all of our u's with what u was when we started this problem with the basic substitution. So we'll go 1/4, and I'll distribute the 1/4 through. Arc sine of x squared, because that's what u was, plus 1/4 x squared square root 1 minus x squared squared, so x to the 4th, and then plus a constant. And that's it. That should be 59. All right, one more. One more. Yay. All right, and I'm recording. See, this video is 13 minutes long. All right. Where the heck is it? All right, integral, ooh, save the best for last. Integral 1 over the square root of 9x squared plus 6x minus 8 dx. All right, we've never seen a problem like this before. And the instructions say, evaluate this by first completing the square. And that's about all I'm going to do. I'm not going to follow the rest of the instructions. All right, so I'm going to complete the square first. So forget all this for now. Let's write down that quadratic that's under the root. See, we can't use a formula for this because all of our formulas have variable squared and then plus or minus number squared. We don't have an x term in any of our formulas. We always have x squared. So we need to work with this first. To complete the square, and I went over this in class, the first thing you need to do, put it in descending order, highest power of x down. Make sure that the number in front here is a 1. So I'm going to pull a 9 out, factor 9 out, and that'll leave me with x squared plus 6/9 x minus 8/9. So if I distribute the 9 back through, I get this expression. That's equal to 9 and then x squared plus, let's see, 3 goes in there, that's 2/3 x minus 8/9. All right, now what I'm going to do is focus all my attention here and do the completing of the square, which means I'm going to look at the number, including the sign, in front of the x term. That's positive 2/3. I'm going to divide it by 2, which is the same as dividing it by 2 over 1, and flipping, and you get 2/6, which is 1/3. So that's my first kind of magic number. And then the next magic number I get from completing the square is this number squared. So I take 1/3, I square it, and I get 1/9. Okay, so that's my second magic number. So what does this allow us to do? We're going to take this, here's our 9 that got factored out. What I can do is realize that there's that hidden 0 right here, right? Plus 0. But I'm going to use this number to write 0. So I'm going to write x squared plus 2/3 x. Now here's my 0. It's plus 1/9 minus 1/9. So that's 0. And then I have minus 8/9. Notice I'm keeping the parentheses, keeping the 9. Now what I have is that the first 3 terms inside that parentheses are guaranteed to factor to a perfect square trinomial. It will be something squared. It'll be x, and then the number here will always be that first special number we got, so plus 1/3. And then over here we have negative 1/9 minus 8/9, that's minus 9/9, that's minus 1. And then our parentheses. So this expression here is equivalent to this expression here. So now I'm going to go back up to the original integral, and I'm going to rewrite it. Integral 1 over square root, and then this. 9, then in parentheses, another parentheses, x minus, plus 1/3, sorry, plus 1/3, that quantity squared minus 1. Then close it off, that root keeps going there, and then dx. And now notice that since 9 multiplies times this whole thing, the square root of the 9 is a nice number. I can pull it out as a 3 and then pull it out of the integral as a 1/3. So I have 1/3 integral, and then 1 over just what's underneath the square root. That 9's gone. So it's this stuff. It's the x plus 1/3 squared minus 1 dx. And this looks a lot like our formulas. We have like x squared minus a squared, except this is not just x, it's x plus 1/3. So now what I'll do is I'll make a basic substitution that u is x plus 1/3. And that means that du is just dx. And then I'll rewrite the problem. So we've got 1/3 integral 1 over, I forgot the square root. Shoot, I'm sorry. Square root right here. Oops. Square root. Then square root of this right here is u squared, minus 1. And then dx is du. And now this looks like our formula. We have u squared minus a squared. Or, you know, we're used to seeing x squared minus a squared, but we're using the variable u. So whenever we see u squared minus a squared, or x squared minus a squared, we use that x was a secant theta, but for us, we're going to be using that u is a secant theta. But a is 1, so secant theta. Du is secant theta tangent theta d theta. And then that square root part, u squared minus 1, I'll let you work this out yourself. This should just be tangent theta. So I'll rewrite this integral right here now. This is equal to 1/3 integral 1 over the square root part we just said was tangent theta. And then du is secant theta tangent theta. Secant theta tangent theta d theta. The secants can't, the tangents cancel. And all we're left with is 1/3 integral secant theta d theta. And we can integrate that because we have a formula in the back of the book for secant theta. So this will be equal to 1/3 natural log, I think it's secant theta plus tangent theta. I'm going to double check. Let me get my formula, tell you what formula this is. Yeah, it's number 14. Natural log secant theta plus tangent theta plus c. All right, so we're going to need a reference triangle here using this information that if this is theta, secant's u over 1, secant's the reciprocal of cosine, so u over 1, this is square root of u squared minus 1. So we have 1/3 natural log secant theta is u plus tangent theta, which is square root u squared minus 1 over 1, so that's just that, plus c. And then remember what our u was. The u, we made a substitution a long time ago that u is x plus 1/3. So we get 1/3 natural log u, which was x plus 1/3, plus square root of x plus 1/3, that's u, squared, then minus 1, plus c. Whew. Oh, goodness. It's good enough for me. All right, that does it. I'm exhausted from doing these problems. But I only have to do them one time. Now I have them on video. I never have to do them again. But they'll probably change the book next semester, so we'll see. That's it. I was thinking about starting some partial fraction problems today, but I don't know if I've got it in me. I might have to wait till next week to get going on those. But all right, well, I hope this really helps, and I'll see you all later.